Hello guys, welcome back to this channel. This video is about how to control AC load using photoelectric proximity sensor. This is magnetic contactor, this is magnetic relay, and this is the photoelectric proximity sensor. This is the SMPS. This device you see here is what is going to help us convert the AC to DC, because the photoelectric proximity sensor uses DC voltage, that is 10 to 30 volts DC. And with the photoelectric proximity sensor, we have three main types. That is the true beam photoelectric proximity sensor, the retroreflective photoelectric proximity sensor, and finally the diffuse or reflective photoelectric proximity sensor. That is the three main types, and we're actually going to focus on the type that I'm having right now. This is the diffuse or reflective photoelectric proximity sensor. And a photoelectric proximity sensor is a device that uses light to detect the presence or absence of an object. And over here is the wiring diagram of the photoelectric proximity sensor. I have the wiring diagram over here, and I've also drew it. We have everything here: the BN, the BU, the BK, and the WH. We have the BN, that is the brown wire. We have the brown wire here. This wire is the positive wire, BN. You have the BU, that is the negative, that is blue. You have the blue at this side as the negative. You have the BK. The BK is NO. There's the output wire, NO, normally open. That is the BK, the black. There's the black. And finally WH, that is the white. How the white here. This is output wire, NC, normally closed. We have the load at this side. Now with this wiring diagram, you could see that we have the positive connected to the load. This is the load. This load you see here is actually the relay we have over here. That is the load. Now you could see that you have the positive connected to the load, and this side we have no indication. This is a DC load, so technically if you have the positive connected to the load, then technically this side is the negative. So this output NO, that is the black, and the white you see as NC, is actually negative wires. You could see that they are linked to each other. We have this point and this point from this side to this side. So it is the same negative wire. It depends on the circuit that you are building. And in this very video, we are going to talk about all these features in the video. So stay tuned as I make progress. You actually have 4 wires, and we are going to talk about all of them in this very video. And before you understand a photoelectric proximity sensor, how to know what is an emitter and a receiver, we have 2 lines over here. And an emitter is a device that generates and transmits a signal or a beam of light, while a receiver is a device that detects and interprets that signal. That is that. With these 2 lanes you see here, one is going to serve as an emitter and the other is going to serve as a receiver. Now you could see that we have the emitter and the receiver in the same housing. This is a proximity sensor, and we have the emitter and the receiver in the same housing. We have one as emitter and the other as a receiver in the same housing. And the object itself is going to act as a reflector. Now, this sensor detects both metallic and non-metallic objects. So if I bring my hand here, something like this, my hand is going to serve as an object and at the same time to a reflector. The emitter is going to throw that beam of light to my hand, and my hand is going to serve as the object and at the same time to a reflector. So it will reflect some of the light being thrown, to reflect it to the receiver. And when the receiver actually receives that light, it is going to either activate or deactivate a circuit. That is how this type of photoelectric proximity sensor works. And you could see that you have minimum here and maximum. We use this section to increase or decrease the sensing range. If you want it to detect the presence of an object at a distance, you have to increase this. Or if you want the object to come very close to it before it works, then you have to actually decrease it. And this is the section we use to do that. This is a plastic screwdriver. I can actually insert it and then turn it. If I want it to be increased, I have to turn it to the maximum section. You have an arrow, so you have to actually check the arrow before you'll be able to either increase or decrease it. And we have the true beam, and with the true beam we have the emitter and the receiver on a separate unit. The emitter is going to be at one point and the receiver is also going to be at one point that is opposite to each other. And the emitter is actually going to throw a beam of light to the receiver. The receiver is what is going to receive that beam of light being thrown by the emitter. They are going to face each other, something like this. Let's say my left hand is the emitter and the right hand is the receiver. Now the object is being detected when it breaks the light beam between the emitter and the receiver. When an object comes into contact, the light beam being thrown from the emitter to the receiver, the object is going to break that link or the beam of light being thrown by the emitter to the receiver. And when the object breaks that link, the circuit is going to either open or close, that is to either activate or deactivate. And we also have the retroreflective. With the retroreflective, we have the emitter and the receiver, something like this, in the same housing. We have the emitter and the receiver at the same place. Unlike the true beam, we have them facing each other, opposite. But with the retroreflective, we have them in the same housing, something like the one that I'm having right now. We have them, the emitter and the receiver, in the same housing. And the object is being detected when it interrupts the light beam between the sensor and the reflector. Now with the retroreflective, we have to actually have something like a reflector. Let's say this is retroreflective sensor and this is the reflector. This reflector you see here is not actually a cloth or something like that. It is a special reflector being made for the sensor. Now when the sensor throws that beam of light to the reflector is then going to reflect the beam of light back to the receiver. You have the emitter and the receiver in the same house like this one, to the receiver. And when an object comes into contact, that is between the sensor and the reflector, it is going to break the circuit, something like the diffuse reflective type, something like this one. But that one we have a reflector. And when it interrupts the light beam between the sensor and the reflector, there is going to be the activation or activation of a circuit, that is to either close or open a circuit. That is how the retroreflective sensor works. And as I said, we are only going to focus on this type. And this type of sensor, the light beam could be infrared or visible light. With the infrared, you cannot see it. And with the visible, as the name implies, you are going to see it with your eyes. And this type of sensor I'm having right now is infrared type. You are not actually going to see the light, but technically there's a light or a light beam. That is how it works. What I will do is to connect live and neutral to the circuit breaker, and from there to the SMPS. And then we proceed with the proximity sensor connections. The red wire is the live and the green is the neutral. I have the live at this side and the neutral at this side. So I'll connect the live from this side to the SMPS. And as I said, the SMPS is what is going to help us convert the AC voltage to DC, because the proximity sensor uses DC voltage. And this is also 24-volt DC magnetic relay. This is 24-volt DC. And as I said, the voltage range starts from 10 to 30-volt DC. And this is 24-volt DC magnetic relay coil. This is the base. The coil is what is going to help us control the magnetic contactor. That is the normally open and the normally closed contact. We are going to make good use of that. The sensor is going to help us energize the magnetic relay coil. This is the neutral. You have live and neutral, and this side is the earth. And this side too, this is the input and this is the output. With the input, we have 2 terminals as positive and 3 terminals as negative. And down with the input connections. What I have to do is to connect the proximity sensor, the negative and the positive. We have the BN, that is the brown, as positive. And we have the BU, that is the blue, as negative. So I connect the positive and the negative to the SMPS, the output side. Okay guys, we are done with the positive and the negative. We are going to use the normal open, that is the black. We're going to connect the black, that is the negative, to the magnetic relay. From the black to the relay coil. We have the coil wiring diagram over here. Now this is the coil wiring diagram. We have a lot of numbers. We have 9, 10, 11 and 12 as common terminals. We have 13 and 14 as the coil terminals. They have 13 as A1 and 14 as A2. That is negative and positive. So as long as this NO, that is the black wire, is negative, how to connect the negative to the relay, the negative side, that is the number 13. So what I will do is to use a connector and connect a cable. This is a connector. I will then connect a cable from this side to number 13. And if you want to learn more about magnetic relay, I'm going to leave a video link in the description down below. If you want to learn more about it, just go to the description and tap on that link. It will take you directly to that video. I'll use this green wire as the negative. Here's the wire. We are using the sensor to energize the coil of the relay. So whenever the sensor is activated or deactivated, it's going to affect the relay. And the relay is what is going to control the magnetic contactor. We have 13 at this side. That is negative. Now, what I have to do is to connect positive wire to the magnetic relay. We have the negative connected. We have the positive already connected to this side. And the negative is what we have connected. That is the BK. I connected it to the relay. What I have to do is also pick a positive signal from the SMPS, the output, to the magnetic relay. So what I will do is to use this red cable and then connect from any of the positive terminals. We have 2 of them. So I'll connect it to one. Okay. We have number 14 as the positive. That is the A2, number 14. We have 14 on this side. Guys, we are done connecting the negative and the positive signal to the magnetic relay. So what I will do is to insert the coil itself. Okay, have the coil inserted. Now I'm going to use a sensor stand. There's a stand over here. This is the sensor stand. What I'm going to do is to turn on the circuit breaker so that we see how the sensor is actually going to work. First of all, I'm going to tape this white cable over here. This is the normally closed. We'll use tape to tape it. Okay. So I'll turn on the circuit breaker. Now, we also have DC on. This DC on you see here is an indicator. So when it lights up, you have to know that the SMPS has received the right voltage, that is the 220 or 230. Okay, you see that there's an indicator here. This is DC on. Okay, the sensor is working. I use the black cable, that is the normal open. So with the normal open, when an object comes into contact, then the sensor will start working. So right now my hand or my body is actually facing the sensor, so there is a connection to the receiver. What I have to do is to let it face this side. You could also see that whenever it starts working, there's an indicator on the magnetic relay and also indicator on the sensor. Okay. So guys, that is how photoelectric proximity sensor works. And at the end of the video, I also connect the normally closed, that is the white, to it to see how the circuit is going to work. That is that. So guys, let me connect the magnetic contactor to the circuit. This is 220 volts magnetic contactor, and before a 220 volt load works, there must be live and neutral. So what I have to do is to connect the neutral to A2. You have A2 at this side and another A2 at this side. These two A2 are linked together. So if you connect your neutral to any of the A2, it is going to work, and A1 is actually the live. So what I'll do is to connect the neutral to A2. I'm going to use this cable as my neutral, the green cable, and connect from this side. Okay, we have the neutral connected. So what I have to do is to loop the live from this side to the common terminal, and we are going to use common terminal number 9. We have number 9 on the magnetic relay socket. This is number 9. So what I have to do is to loop the live from the breaker to the number 9. And I'm also going to use this red cable to loop the live. We have number 9 at this side. Now we used number 9. We have number 5 as normally open and number 1 as normally closed. There is a bar over here, and this bar is linking directly to number 1, and at the same time to number 5, but this time around it's normally open. So when the relay energizes, the open is going to tend to close and the close is going to tend to open. So I use number 5, that is open, and connect it to the magnetic contactor, and this wire is what is going to be the switch wire. I have number 5 at this side. This is number 5, and the down here, the opposite side, is the number 1. Okay, you have A1 at this side. So guys, that is that. This is how to control AC load using photoelectric proximity sensor. And you are successfully done with it. So what I have to do is to turn on the circuit breaker, and then you operate the circuit. I've turned it on. Now when an object comes into contact with the proximity sensor, and then it will work. You have the DC on at this side. Just now my hand is making it work. I can also bring this paper. Yes, it's working. This is a diffuse or reflective photoelectric sensor. We have the emitter and the receiver in the same housing. The camera is actually making it work. We have two lenses. One is the emitter and one is the receiver. So if I do something like this, now this paper is serving as an object and at the same time to a reflector. So when the emitter throws that beam of light to the paper, there's a reflection to the receiver, and when the receiver actually receives that signal, it is then going to operate the circuit. So you're going to either turn the circuit on or turn it off. That is how it works. And currently we are using the normal open, and with the normal open, when the sensor detects the presence of an object, then it closes the circuit. That is to turn the circuit on. Yes, it's working. So guys, that is that. That is how to control AC load using photoelectric proximity sensor. You can actually increase the sensing range. This is a plastic screwdriver. I insert it, then turn it, something like this. Yes, the sensing range has been increased. It's still working. And with these three types, that is the true beam, the retroreflective, the diffused or the reflective type. That is what I'm holding right now, the diffused or the reflective type. The one that offers the longest sensing range is the true beam photoelectric proximity sensor. And this type I'm holding right now offers shorter sensing range. So if you want the sensor that has the highest or the longest sensing range, you have to go for the true beam. So guys, that is that. And I'm actually going to turn off the circuit breaker, and then we remove the cable from the normal open to the normal close. That's the white. What I have to do is to remove the tape I have one connector here, so I'll connect it to it. And remove the green cable. That is the black. I have the black as normally open. So I remove it and connect it to the white that is normally closed. And when I connect it to normally closed, automatically the sensor will start working. That is normally closed. And when it detects the presence of an object, then it will go off. That is how the circuit is going to work. So right now we have the white cable connected to the magnetic relay. You can actually see it here. This is the black, this is the white. I've connected it to the magnetic relay. Now I'm going to turn on the circuit breaker. Okay, the contactor is working. When an object comes into contact, look at this. So right now it has detected my hand. There's an object over there. And as I said, this type of sensor detects both metallic and non-metallic objects. Yes, this is a metallic object. So guys, that is that. If you find this video helpful, consider subscribing to this channel and turn on the notification bell so that anytime I drop a video, YouTube is going to notify you. Thank you for watching this video and see you in my next video.